In this video, we're going to look at 3D coordinates and coordinates in general. And you've done a lot with X's and Y's and two-dimensional coordinates. So we want to kick it up a notch and look a little bit at three-dimensional coordinates also. But before we get to three, let's just look at one-dimensional coordinates. One-dimensional coordinates are a single number line. And if we said, where is 1? Well, we'd say that's the dot, that's the point right there, 1. That's a one-dimensional. That's the number line back and forth, left and right. That's one dimension. If we go two-dimension, we now have left and right and up and down. So if I had the point 1, 2, I could go right 1, up 2. And that is how we're used to Cartesian coordinates planes, as it's called, with our X's and Y's. But there are other ways of doing coordinate systems. There's another way that's known as polar coordinates, which we will look at later in the year in much more detail. And instead of saying you go over an X and then up a Y to get to a point, instead, this is where you just turn an angle and then go straight out. So instead of saying, you go over 1, up 2, you say you turn 30 degrees and you go out 2. A completely different way of doing it, but still works. Now, if we look at 3 dimensions, we now have an X, a Y, and a Z. Now, they turn it a little bit, and they make this horizontal axis our Y. The vertical axis is our Z, and then this X-axis is kind of coming straight out of the board, straight at you. It's hard to picture 3 dimensions on the flat surface, but that's what we're looking at here. So we now have the coordinates X, Y, Z. So if I have the points 2, -1, 3, that is 2 in the X direction, so here's the X. So I'm going to come out 2 this way. -1 in the Y direction, I move over 1, -Y. And now I go up 3. I go up 1, 2, 3. Now, we draw these lines because if I just put that point there, it's really hard to see where that point is without the lines, if I got rid of the lines. Is that point back, over, and up? And now it's behind kind of the page. Is it forward, over, and up like it was? Is it back even further, over, and down? It's really hard to tell where that point is without drawing our lines. So because of that, we always want to draw our lines. Now, when we draw these lines, a few other things. We start and we go out 2. So we come out this distance right here to 2. Now, our Y is -1, so I'm going to move the left 1. Now, I'm not going to, here is -1, here's -2, here's -3. And you say, well, if I go over 1 to here, notice I'm almost all the way out here to -3. That doesn't seem right. But I'm starting here, so I'm moving over 1. If I move this back, you can see that that is 1. So I go over 1. Now I want to go up 3. So if you want to, you can think of starting here, go up 1, 2, 3. So there would be up 3, but I don't want it there. I want it at the end of my line. So I go over here, and there is where my +3 is. So you have to kind of look at where you're at to figure it out. Now you say, well, this is only at about 2, but I'm already down here about -1 to get my point. Okay. So another one. -1, 2, -2. So X is -1, so I go back -1. Let's switch to red, I think it's easier to see. Back to -1. Now I have to go right 2. So I go 1, 2 is to there. And now I go down 2, 1, 2, and I go right there. Okay. Now, I guess I should point out, I've been kind of assuming what was going on, and maybe I need to be clearer about this. If we had this graph, this is our positive x-axis, 1, 2, 3, 4. Back here is the negative axis. And the y's and z's are just like we're used to, 1, 2, 3, 4, -1, -2, -3, and then the z's are 1, 2, 3, 4, -1, -2, -3, -4. I'm not sure if you need to label those, but that may that now it looks really confusing once I put them all on there. But this is the positive x-axis is kind of coming out at you. So let's graph another one. I'll give you a second to try this one yourself. 3, 1, -2 on your notes. See if you can graph where that point would be at. I'll give you a few seconds. If you don't get done, you can pause the video and then try to do it yourself. All right, we're going to come out 3 to there. We're going to go right 1, and then we're going to go down 2. And right there is my point, 3, 1, -2. Now, just as in there's other kinds of 2D coordinates, polar coordinates, there are also things like cylindrical coordinates or spherical coordinates. These are other ways of labeling a point. And many of these, once again, use the angle. In this one, you can see this one, you start here, you go over a certain angle theta, then you go out y and up z. That's cylindrical coordinates. Here, you go an angle this way, you go an angle this way, and then you go straight out to get a point, which is called spherical coordinates. We're not going to work with either of those, but there are other ways of doing it that are out there. Let's talk about distance a little bit. If we have the distance between 2 points, if I want to know what's the distance between 1 and 5, well, we would say, well, the distance is 4. And we would find that by taking 5 minus 1. Pretty simple. If I said, what's the distance from -4 to 3? We would say, well, that would be 7. And we would get that by taking 3 minus a -4, which would be 7. Now, you may get messed up and say, well, what happens if I switch them and I took 1 minus 5 and I got -4, or -4 minus 3, which would give me -7. So many times what we do is we say you subtract, and you maybe put absolute values on there because distance is always positive. But the key to get distance is subtraction. That's in 1 dimension. Now, if we go to 2 dimensions, we want to find our distance between these 2 points. So we want to find how far is it from point A to point B. And there is a distance formula, and I want to show you real quick kind of where that distance formula comes from, because once you understand where it comes from, you almost can get by without really thinking about it. If this is a point here, x1, y1, and this is a point up here, x2, y2, I can find my distance by creating this triangle. This right triangle that I've created here. So now what I can do is say, well, if I have this triangle, I can use Pythagorean's theorem. We have to remember that. A squared plus b squared is c squared. And I know the length of this side is x2 minus x1, because this is just in 1 dimension. It's from the x to the x. And I know the other side is in 1 dimension. It's just the y's. So it's y2 minus y1. And this side is my distance. So to find my distance, I could just say that my distance squared is x2 minus x1 squared plus y2 minus y1 squared. I can just do Pythagorean theorem. And then my distance would be the square root of that. And now we end up with the distance formula that you all know and love from algebra, in geometry, and so forth. So there's our distance formula. But you can almost get by without thinking about that, and let me show you what I mean. If we had an example, and I said, well, what's the distance from this point to this point. And we could go the distance formula. This is the point, negative 1, 1. This is the point, 3, 4. And we could do that. However, an easier way to do this is to say, well, let's draw a triangle. And we know this side of the triangle is 4. This side of the triangle is 3. So what's our distance? Well, 4 squared plus 3 squared equals our distance squared. And we can figure this out by using the Pythagorean theorem without really using the distance formula that we have. Now, we could do the distance formula and say the distance is equal to the square root of 3 minus negative 1 squared plus 4 minus 1 squared, which is the square root of 4 squared plus 3 squared, and you get the same answer. But that's a little bit more work, and you got to remember the formula. Now, what happens if we go to distances in 3 dimensions? It's really hard for us to look at this and see that distance. We can't even picture that line in 3 dimensions. So in 3 dimensions, we got to use that formula again, but instead of just x's and y's, we now have the same formula, but just z's. We subtract the x's and square it. Subtract the y's and square it. And we subtract the z's. And we square it. Add them all together, the square root. And that is how we find our distance formula between 3 points. We just scale it up. Now we also want to talk about the midpoint. So if I want to find the midpoint between 2 points, it's the middle. Well, how do you find the middle of 2 points? Well, you would take 5 plus 1 divided by 2. You find the average. And there's our middle. So when we find the midpoint, that's all we're doing. When you think midpoint, think average. Now there is a formula. I'm going to write it down. But I don't want you to think about this formula, because this formula makes it more complicated if you try to remember a formula. Think midpoint as averages. How do you average 2 numbers? You add them up and divide by 2. You already know that. Don't learn some new formula. So if I want to find the midpoint, I average the x's. Well, how do I find the average of 7 and 3? I add them up, I divide by 2. How do I find the average of 2 and 7? I divide them up, I divide by 2. So when you see midpoint, think average. And then the same thing happens when we get to 3 dimensions. You add them up and you divide by 2. You average the x's and you get your answer. You average the y's and you get your answer. You are now ready to do the homework for 3-dimensional coordinates.